Okay, hello everybody. So I'm Florent Garin from WebGL. We are a company based in Toulouse, and we develop digital platform for the industrial sectors. So I will talk a little about the project. And after, my presentation is focused on a new feature we just implemented, which makes two very promising technology, which is WebGL technologies for 3D on the web, and also real-time web technology, or real-time web technology like WebRTC and WebSocket. So I will present you both technologies, and after I will make a demonstration on how we mix them both. So briefly, the project is WebGL PLM. PLM stands for Product Lifecycle Management. It's basically it's a project which are used by industrial manufacturer, which use to manage all their data. So there are several modules in such a product. We have a document management module. We have a product structure module. We have product configuration, because every product is managed under configuration. We have a change management. Change management is a big part of the product, because, for example, if Airbus make a change on a system, they need to evaluate the cost. They need to evaluate the impact, etc. So this is this is not the subject of my presentation, but this is a model we are heavily investing in using big data technologies to make some prediction on the impact of a change. Okay, so my presentation today is about the data visualization model and the collaboration module. So this is a slide on what technology do we use. So the backend is mostly developed in regular Java EE7 stack. We use also Elasticsearch for indexing documents, indexing parts. The front end is developed using Backbone.js. We also use Angular, but most of the front are developed in Backbone.js. We also have Node.js on the server. Actually, we use Node.js in two different ways. We use Node.js on the server side. I will show you how do we use that. I will explain you in details later. But we also use Node.js because even if most of the software are web-based, we have a small native module, which actually it's native, but it's developed also with web technology. But it's packaged with Node WebKit. It's packaged on a native application. This is the tool the CAD user use to communicate from his authoring tool and to our server. This is a plugin he can use from Katia, for example, to push and to download all the CAD files. And this part is developed using Node.js, Node WebKit. So this is the technology we use. So Okay, so for the visualization, we rely on WebGL. WebGL is it's an awesome technology because it allows you to make 3D on the web without any plugin. Now it's quite mature because there are many open source engines built on WebGL, which is a low level API. You cannot develop directly with WebGL. It's very low level. You need to choose an engine. Actually, we selected 3GS, so we took 3GS, and from that, we had some feature dedicated to digital mockup visualization. Because there are lots, 3GS is a generic engine which is more dedicated for game development. So we had to develop lots of things above 3GS to make it usable for in industrial context. Okay, so I don't know if I have much time, so perhaps I will switch direct. 5 minutes? No? Okay. So I talked on Node.js. So we have on the front end we use 3GS engine to make the 3D visualization, and we wanted to make some computation on the server side. For example, to calculate the center of gravity, to calculate the weight surface of parts, etc. But the problem was we need to have the computation result have to be exactly the same on the front end and on the server side. So at the beginning, we developed a Java model to do the 3D computation, but the result could be different, and that was an issue. So we decided to use Node.js on the server side, so we have exactly the same library, the same context for 3D computation on both sides. This is why we use Node.js. Also, Jean-Baptiste said he didn't want to do JavaScript development because there's no thread. Okay, that's true, but we don't have real thread, but we have web workers. This is not exactly a kind of thread, but it allows you to launch some JavaScript treatment on the background. So it's very hard to do interesting things with that, because we cannot create web worker from web worker, and web worker can only exchange stringify data with the main thread. So it's not the perfect solution, but it's there, and we also use that to improve the performance on the 3D. We do most of the computation on the background, on the browser. Okay, so I will show you that. And after that, okay, for the real-time web. So there are also many different API in HTML5 now. We have server-send events with a kind of comet. You can think of that like if it's a comet which has been standardized, actually. So you can push data from the server to the client. It's not very clean technology, but it has the advantage to be HTTP. Another solution is to use WebSocket. WebSocket is better than server-side sent events in the fact that it's a full duplex protocol. The server can push data, and the client also, in the same time, can push data. You can communicate in the both way. But it has the disadvantage to it's not HTTP. It's very far from HTTP, but actually it's not HTTP. So sometimes some proxies, some if you use a 3D or 4G connection, the communication will be closed. So there's lots of issue with that. WebRTC is a technology. It's a part of HTML5 where you can implement a kind of Skype directly with JavaScript technology. So we use it, we implement it in our platform, and users can communicate with that. It's awesome technology because it's include the ICE and STUN protocol, which allow you to make some NAT transversal. Even if two people are behind a NAT, they can communicate. And also, automatically, any browser which has a WebRTC API, it finds the best network path. So if we engage communication with your colleague, which are in the same network, the video stream will go directly without going to the HTTP server. Okay, very short video. So this is two computers. Okay, the first one display the model. He has invited the other one, and when we use it for review, DMU digital mockup review. When this one moves the model, it is reflected on the other PC. So he can select a piece, he will take a part, move it, move that part, just to show. Okay, he will select a part, move it, okay, and the other can exactly see the same, which move, okay, and they both communicate through WebSocket, which is very performance because we don't. It's not based on screenshot. We send only primitive of movement. That's it.